Thank you, and thank you for the warm welcome. Thank you all for joining me today. Hopefully, it's a nice start to your morning. Hopefully, you're already awake. If not, I'll try my best to keep you awake. So before we start, just a few things about me. I'm a software engineer at the LEGO Group, and I'm an AWS Community Builder. I'm passionate about serverless, and I do mostly backend. So these are kind of my area of expertise. But I won't bore you with that. Before we dive into our automating the API client onboarding process, I want to start our journey with telling you a bit about LEGO and where do I fit in the organization, just so you can have an idea of what we're dealing with and why do we need this process. So LEGO has a few different departments. One of them is the Marketing Channels Technology, or MCT, and I'm part of that department along with many other squads. We do take care of Lego.com, all of our retail store operations, as well as our customer support center. So these are kind of the areas that we're looking at. Now, inside of the MCT, there are different squads. I'm part of the Loyalty Services Platform squad. So we handle LEGO Insiders, rewards, VIP membership, and all of that stuff, including the VIP in-store experience. And I just want to walk you a bit through kind of like a journey of a customer and where do we fit in with that. So we have our loyalty customer. They come into one of the LEGO stores. They look around. They try to buy one LEGO. Probably they end up buying 2 sets if they're like me or more. And then they go to the till. And once they're at the till and they try to make the purchase, that's when the apps at the till make a call to our loyalty services. What happens there? Well, there are 2 things that can happen. One, you already are an existing VIP, so we look for the rewards, if you have any, and we select them, and then we place the order. Or you're a new VIP, so there are no rewards for you yet, so we just place the order. So these are kind of like, this is a very simple flow of what happens when you come into a store as a VIP customer. Now, the loyalty services also talk to other external applications throughout this process. We can also talk to Lego.com. We interact with an in-house order service as well. So there are lots of things happening. And the way that we achieve that is through some public APIs that we expose to our clients or consumers. So just to give you like another overview, so as I've mentioned, there are lots of different other services that we interact with throughout the processes, but inside our loyalty services bounded context, we have a lot of microservices. So each microservice has one responsibility, whether it's orders, members, rewards, or so on. And they all communicate with each other through events. So this is kind of how the loyalty services operate. And as you can see, we already have quite a few consumers, but as we expand our platform, that number of consumers grows. So we felt that we need to improve our onboarding client, API client journey because, and when I say clients, I want to stress that when I mean clients, there are other like services, other squads, whether they're internal or external, they're not end users, so they're not LEGO buyers, it's just other services that want to interact with us. And we feel like we need to do something about this. And the first step on our journey will be looking at how does this scale. Well, for instance, we have our loyalty core API, and that API has 1 client. That's manageable, right? There's not much to do, just onboard 1 client and you're done. But we also deal with rewards. So we have our rewards API, and that has its own set of clients. We have a members API, and that comes with its own set of clients. It's already kind of starting to grow, and it's harder to manage manually. But what happens when you have clients that need to consume from both or all 3 of the APIs at the same time? And not all clients will need access to the same endpoints of those APIs. So it's already started to become a little convoluted. And with the number of clients growing, so is the time that takes to onboard these clients manually. But that's not all. I keep mentioning onboarding a consumer or a client, but what does that exactly mean? Well, you have your API consumer that you want to onboard. That means you need to create some sort of client and specify some scopes, a token validity, and any other parameters that you might want to add. You then might want to create a usage plan and associate an API key with that, as well as some throttling and quota limits. Then you need to find a way to temporarily store those credentials that you've just generated. And then last but not least, securely deliver them to your consumer. So you probably build a text file and send an email. So these are quite a lot of steps that you need to take. And if you're doing this process manually over and over, it can be prone to human errors. Lots of things can happen, so why not try and automate this? So let's look at things like this. We can try and group them. So there are kind of like 4 main steps that we're looking at here. So the client creation, the usage plan, storing those credentials, and then delivering them securely. You're going to hear me say a lot of times, security, 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 and I'll get to why in a second. But let's try and start to build a flow on how we would actually build this using AWS services. Well, these are the main steps that I've outlined. But before we dive into that, let's think about some of the considerations that we might want to have. For instance, when you create a client, you might want to check that it's unique. You don't already have a client onboarding with that exact same name, because that might cause problems down the line. Again, an usage plan is not enough. You want to make sure you create an API key and you link it to that usage plan. When you store those credentials, again, security needs to be at the forefront of your thinking. The data that you're generating is sensitive, and you want to make sure that there are no security breaches in your system. And then when you say send credentials, I don't know about you, but I think of a subscription-based interaction. So you subscribe your client to a topic, and then that way you have an automated way to send information to that client. So using all of those steps, you can slowly start to build a logical flow. So you have your input, you create your subscription, so you have that connection with your client, so you can later send everything you've generated. And then you move on to generate everything that it needs, and last but not least, send them. Now, how would these steps communicate with each other? Well, through events. So you can pass on various events from each step and then use the input from the previous steps and from the events to move on to the next one. So we're slowly starting to get to an event-driven architecture, so we're slowly building onto that. But before we dive into how we can leverage AWS services to do that, let's take one last look at exactly what we need. So we'll need an input, some sort of input that can come through an endpoint. And then once we've received that input, we might want to validate it to make sure that whatever we've received is valid, the data is not malformed or anything like that. Once we've done that initial bit, we can then move on and create our subscription. Once we have the subscription established, we can build our scopes, our client, and the token validity. Once we have this client and the client secret that comes with it, we can then move on and create our usage plan, our API key, set our limits to make sure that we have a bit of control of how many access points we have throughout the day for our API. And then once we've generated everything, we can prepare we can use a script to prepare a text file and then store those credentials in the text file in a secure way. And then last but not least, we will prepare the email and send that through to the client. Okay, so I think now we have an understanding of the use case and how we're planning to do it. So let's dive into the AWS services and how we can leverage them to achieve this. So first, let's look at the client requests. So you have your client, and then that client makes a request to an endpoint that sits behind an API gateway, and then that request goes to a payload validation lambda that does all the checks that you want it to make. That lambda then sends a response back to the client saying, this has been validated or there's something wrong with it, but this will be an async response. So just because the lambda said something back to the client does not mean that everything's done now. And then the lambda will also emit an event onto the event bridge. A few things I want to highlight here. So we'll have an OAuth flow on the API endpoint to provide some extra security on it. And then there are things that we might want to consider in terms of the payload. So what exactly do we need in the payload to be able to build all of this? So you probably want things like a client name, a client email, the scopes that the client needs access to, and if you want, you can specify certain quota and throttling limits. If not, there are going to be default values associated with them. And another thing that I want to highlight here is a structure of the event. So at the LEGO group, we have some standards that we follow. We usually, in the detail, we have a metadata and a data object. So we store different things in that, in those two fields. And it's really good to kind of try and stick to a pattern and push as many events as you can for observability purposes. So once we've validated our payload, then we can move on to our consumer subscription. So we want to create that subscription for our clients. How do we do that? Well, remember that validated event that we put onto the event bus? We're going to use that to trigger a step function. And inside of that step function, what we'll do is we'll create an SNS topic. We'll then subscribe the client to that topic. We might want to store some details in DynamoDB for traceability purposes. And then, last but not least, we'll emit another event and put that onto the event bridge. A few things I want to highlight here. So one is that the topic would be unique per client. And the reason why we're doing this is because the data we're generating is very sensitive. So we want to reduce the possibility of sending the wrong data to the wrong client, because that would be messy. So for security purposes, we're going to keep one topic per consumer. But that topic would be deleted on completion, so we won't just create it and leave it there forever. Once we finish the process, we'll go and do a proper cleanup and remove the topic. The subscription type will be a email type. As we have the email from the input, we passed on to the endpoint. And then, yes, the subscription created event is just for observability purposes. However, there's one more thing we want to do here in this step function onto the event bridge, and that is we want to create an SNS role. And why is that? Because when you create a topic in a subscription, that subscription is pending verification, and that means that somebody needs to take action and confirm that subscription. We don't want to move on to the next step and generate the client credentials before we know that this email has been verified. And the way to do that is we build an event bridge role that will look for certain things. So first of all, in order for you to capture this event, you need to have CloudTrail enabled. I know it's a bit expensive, but usually in production environments, you have it enabled for traceability purposes. Then the source of the event is AWS SNS. So it's an event that gets generated by AWS, and it's caught onto the default event bus. Now, you know that the event name is subscribe, so you can build a rule to match on that. You want to make sure that you only capture the events that confirm that the subscription has been validated. And then you can try and match on the topic ARN because you will know the structure of your topic ARN. You've built it in a previous step in your step function, so you have access to that information. So you build this rule. And, oh yeah, and you also have your consumer subscription ARN if you want to use that in your rule. But probably because we're having one topic per client, the topic ARN would be enough in this scenario. But anyway, it's there if you want to use it. So then the next step is actually generating and sending the credentials. So how do you do that? Well, you have that SNS subscribed event that comes onto the event bus, and you have the rule that would capture it. And we'll use that to trigger yet another step function. And what happens in this step function? We create our Cognito client, where we specify our scopes and the token validity and every other parameters that you might want to specify. You also create the usage plan in parallel with that, and make sure you also create the API key with that and link it. Then you move on and you store those credentials. Then you leverage the SNS publish functionality to send an email to the consumer with everything that you've generated. And last but not least, you publish another event onto the event bus. Now, I've mentioned this, so you want to make sure when you create your usage plan that you also create your API key and you link it to that usage plan, so you establish that connection. And in terms of storing the credentials, you might want to store them in an S3 bucket. You can make that private, and that gives you a certain layer of security. But that's probably not enough. So what we'll do is we'll also pre-sign the URL and give it an expiration time, just to make sure that everything is as secure as possible. And we'll use that pre-signed URL and send it on the email that will get to the client. The SNS publish will just send the email to the client. And then we have as usual, our custom event for observability. Now, technically, the process is done now. But throughout this process, you've created several different things that you do not want to hold on forever. And again, you don't want to go back and manually delete stuff from the AWS console. So you need to implement some sort of cleanup functionality. And one way to do that is we create another rule onto the event bridge, and that's for the S3 bucket. And that tells us, the rule that we're going to build tells us that the object has been downloaded. So similarly to the one where the SNS subscription was confirmed, if you have CloudTrail enabled and you're looking for an event that comes from AWS S3, you can see that there is an event that's going to come in. It's called getObject, and that's basically AWS's way of telling you this object has been downloaded. So you know that the credentials reach the client. It's safe to do the cleanup on your system at this point. Again, you can match on the object ARN or the S3 bucket ARN. You have these available from the previous step in your step function, so you can easily build your rule. So what happens next? Well, the cleanup process. So what do we do with that? Well, we've captured our S3 object downloaded onto the event bridge, and we trigger our last step function. And the first thing that we do in this step function is we delete the SNS and S3 rules. That's the first thing we do. Why? Because it's expensive to keep them. Then we delete the SNS topic, any stored data that we might have put into DynamoDB throughout this process, and we don't feel it's needed anymore. And then last but not least, you want to delete the S3 file. Again, just stressing out that they're the first ones to delete because is cost efficient. They're cloud-free rules, so they're quite expensive. We don't want to have them lying around for more than we actually need them to. The SNS topic is no longer needed. It's fulfilled its purposes, so there's no point in keeping it. And then, again, just removing any temporary data from this. And this is kind of how we can automate this process. But I want us to have a look at the whole architecture. And I want to stress out that the event bridge is at the core of this system. So we have our first part where we have the client request with the validation that emits an event, and then that event is used to trigger the step function that handles the client subscription. That step function emits events for observability, but then also creates that rule onto the event bridge for capturing that the client has actually subscribed to your topic. That then gets used to trigger our second step function, the one that actually generates and sends those credentials. We have events for observability purposes, and then we have the S3 downloaded object roll onto the event bridge that triggers our last step function, which is the cleanup process. So as you can see by looking at this very convoluted diagram, that the event bridge is at the core of our system. Now, I kind of want to walk you a bit through the architecture journey that I took when I designed this. And just want to kind of talk through the bits that happened. So had an initial discussion, understanding the use case and the requirements is always important. And then I dove right into solution design. This is where you come up with the architecture, you do your data modeling, whether it's the event structure or the DynamoDB modeling or both. You need to think of threat modeling in this scenario, and I'll get to that in a second. And then last but not least, it's always a good idea to have some sort of event storming with your team to make sure you're capturing everything. Also, if you want to know more about solution design and why they're very beneficial in coming up with complex architectures, please feel free to scan the QR codes and have a read of these two great blogs written by Sheen. And then I've mentioned threat modeling, and we're following the stride model here. So there are a few things that we want to take into account when we're dealing with things like client credentials. So to mitigate against spoofing, we have that one topic per client. We generate pre-assigned URLs and have privileged access to resources to prevent tampering. For repudiation, well, we have CloudTrail enabled, so we can trace who did what, took what action in the environment. Again, similar things applied for information disclosure. We have OAuth enabled and controlled scope to deal with denial of service. And then again, last but not least, privileged access to resources for elevation of privilege. So these are all things that you need to keep in mind when you're doing a design of a system that has quite sensitive data in it. And before I let you all go, just want to leave you with some key takeaways. First of all, event-driven architecture at the core of the services. Without the event bridge and the event-driven architecture, it would have been very hard probably to do such a system. Security and threat modeling considerations, again, I talked a lot about it. You probably got sick of hearing me talk about security, but it's something that, especially these days, we need to keep in mind. Exploration is key to finding new solutions. I know for me, I've explored various different options before I settled on this particular AWS services, and it was quite interesting to have that opportunity to look into things that I might have not had a look at if it wasn't for this. And then last but not least, break down the problem into different parts when building a more complex system. And that's it. Thank you.
any questions for Andreea?
Did you have an experience handling errors within step functions or between your event bridge, and how do you go about designing that resilience in?
Sorry, I can't hear you.
So did you have any experience dealing with errors within your step functions and within the event bridge, and how did you handle that in some sort of automated fashion?
Yeah, so we do have a bit of, in my team, we do have quite a lot of like step functions, and we deal with event bridge quite a lot. Usually it's a matter of making sure we catch all the errors and then kind of go into an analysis of, is this error retriable? If it is, what do we need to do in order to be able to retry it? So I think it's on a case-by-case basis. In this scenario, I think there are some things that might be hard to retry, because you'd have to go in, clean up everything you've created previously, and then try again. But it's definitely possible, I think.
Hi. In your example, you send an email to a client and there's a pre-assigned link and stuff. And then when they download it, it automatically creates an event and then it deletes the resource. Does that mean they can only download it once and then it's gone?
Yes.
Okay.
Yes, it's one of the limitations, I guess.
Okay.
Yes.
Any more questions?
Hello. I was wondering what you was using for like the throttling and usage stuff.
Why did we?
No, like what technology or how were you managing that?
So we just set these limits on the usage plan that sit behind the API gateway. So we use the API gateway service from AWS to handle that.
Hello. In terms of the metrics of success, would you be able to just go through just one or two, I'm sure there's many, but that you saw as a result of going through the architecture?
Sorry, can you repeat that? I couldn't hear it.
Yeah, sure. In terms of the metrics of success,
yeah.
Would you be able to just go through one or two that you saw as a result of going through the project?
Yeah, I mean, this is almost in production. It's not in production yet, but I think from what I've seen so far, implementing it, it definitely makes the process easier, and it kind of takes care of any human errors, if there are any. So I don't have any like measures to share with you yet, but I can come back with that once we do have them.
So in terms of onboarding, how do, I guess, clients discover this process? And
Sorry?
How do clients, I guess, discover this process in terms of?
So there are already certain steps that we do follow manually. So things like creating the Cognito client and the usage plan, like all of these steps we're currently doing manually, and there are processes that are built in our platform. So it was kind of, how can we automate following these exact same steps that we're doing at the moment? So it was kind of a given because we already have some things in place.
Question from me, is there a manual approval step that's needed before somebody can subscribe, and how do you handle that?
Yes, so when you create a subscription to the SNS topic using the AWS services, then an email gets sent by the SNS to that email that you've used to create a subscription. So that's automatically sent, and then that person just needs to click on the link that says confirm subscription. And once you click on that link, that's when the SNS event gets emitted. So that's...
Yeah, I was also wondering, like, as well as the person who wants to subscribe and get that, like, what if they're not allowed to? What if it's some rogue actor within the organization? Do you have to have some other approval step?
Potentially. I haven't considered that, but it's something get to think about.
Hiya. In the step functions where you were creating AWS resources, so the SNS topic, was that just a case of running a CloudFormation stack to create those resources, or were you doing it differently somehow?
So in our team, we're currently using CDK. So everything is created through the CDK constructs.
Don't worry, it's not a question, it's an answer. So I think a couple of questions they asked, how do you know, who to onboard, etc. So basically, this service as a solution will, as part of the business team. So when a new consumer or client, onboarding process is due, there'll be a team, they handle their request, and not necessarily the end client users will use the API. It's mostly the team in between the engineering and the partners who will have the access to hit the endpoint and create the setup. Yeah.
Thank you, Finn.
Hi. Sorry. You talked about payload validation very early on after the endpoint. How are you achieving that? Is that through Lambda, or are you using any other services like AWS WAF?
No, so it's a Lambda. We do use things like the Zod library for schema validation, and then there are certain things that we might want to check. So in that Lambda, you can check whether you have a Cognito client with the exact same name to avoid clashes, or you want to make sure that, if you remember in the payload, we also pass the scopes. So you want to make sure that those scopes are valid, actually exist in Cognito. So we do those kind of checks in that payload validation Lambda.
Yeah, thank you.
Hi, I'm just wondering what's your SLA? I know you said it's not quite productionized yet, right? So what's your expected SLA?
I'm not sure. It's hard to give an estimate, but I think we're quite close to it. So I'd say probably a few weeks.
How does the architecture deal with updating the scopes of credentials? So if I want to give a client access to a new area in the system.
So currently there's not an update opportunity. It's probably something that we'll have to iterate on in the future. So yeah, currently it's not possible. The system doesn't handle it.
Any more questions? That was a lot of questions already. No, if there's no more, then there are.
So this new approach you've designed, is it a completely greenfield system, or have you had to replace like a number of existing systems, or is it just a series of manual processes that people were doing for onboarding?
No, so this is a brand new microservice. It's kind of like a greenfield project, if you want to call it that. It's something we didn't have and wanted to do, so it's kind of started from the beginning and built a new microservice for it.
Do you have like a plan? Do you have to onboard any like existing clients over to the new method, or will they not experience any disruption when you go live with this?
We don't expect any disruption, given the fact that currently the process is manual. So once we go to production, it'll just be a matter of actually using the build endpoint to handle all of this, rather than going into the console and manually creating all of these big credentials.
Thank you.
Any more questions? Well, obviously that prompted a lot of thought from all those questions. So, yep, let's huge thank you again.
Thank you.